So in this lesson, we're going to go through the history of the atomic structure and basically the history of the atom. And really this focuses on a lot of what we started with in terms of observation. Let's see. And inference. And what we'll notice is that the people that we go through will really made different observations and try to come up with an inference or a best guess of what they think could be going on. Okay, and really the focus of this too is just trying to figure out what things are made of, like what is the basically building blocks of everything that we have around. It's going to start with a guy named Democritus, and Democritus was really around 460 BC, so a really long time ago, over almost 2,500 years ago, or 2,500 years. And what happened with Democritus is he basically made observations with this tool down here. So this is called a mortar and a pestle. And basically what it's used for is just to grind up. So you see they have like corn kernels, and basically what you do is you would grind up these corn kernels. And what he did is he said, well, there must be something that is kind of the building block of everything around us. And so he's really the developer, or the first one that's really known to have the idea of atoms, and he did that by pounding up materials smaller and smaller until he basically couldn't find any smaller of a piece. And he said, well, these smallest pieces must be basically the building blocks of everything around us. So he called these particles atoms, and his idea was basically if you take this object and you cut it in half, you're going to have this half. And if we cut it in half again, we'd have this half. And if we cut it in half again, and basically if we continue to cut this object in half, we're going to get smaller and smaller and smaller piece until we get down to what he thought would be like the smallest piece, basically one that you could no longer cut in half. Right? And so he called them atoms, and this basically comes from a Greek word, which that Greek word means to be cut or divided. And basically it means it's indivisible. So it basically is the smallest piece that can no longer be cut anymore. So that's why he called it something of an atom. Now, his thought of an atom was that atoms of different materials all had different shapes and sizes, and they looked different. So the atom of a fire looked something like this, or the atom of air or wind looked something like this, or the atom of a tree looked something like this. And so everything kind of had its own atom. So every object, every living thing, every unliving thing had its own type of atom, and those atoms were specific to that object. However, his ideas didn't really take off, mostly because this was 460 BC. This type of thought, this type of idea really wasn't useful at the time. So there was really no experimentation that was done to support his idea, as well as it really couldn't answer some of the basic questions that people had at the time. Really, if everything was made up of these small atoms, what kept everything together, and why can't we see them? Right? So if things are so small, really are they actually there? And there was other ideas. There was a guy named Aristotle, which really was kind of Democritus' counterpart in terms of his ideas of how things were made. He really had this idea of like 5 main elements, earth, wind, air, and water, and everything was made up of some combination of those main things. So Democritus had this idea, is kind of written down, but it really didn't do anything for society then. It really wasn't that beneficial. So you'll notice we jump a huge amount to 1808, so almost over 2,000 years, till we really come up with the first time that the atom really starts to take shape, and our idea of what an atom is, and our idea of what things are made of really starts to take shape. So John Dalton was actually a teacher, and in some of his experimentations that he did on the side, he dealt with a lot of gas and how gases are going to react with one another. He basically came up with the modern atomic model that we have today, and he's kind of the founder of the idea of the modern atom. So what he did was he suggested that all matter was made up of these tiny spheres that he called atoms, and these spheres could bounce off one another, and they would lose no energy. And really, you'll look at that more when you get into chemistry. But what he said was that at the time they had learned of things called elements, basically different types of material that were not made of anything. They were just elements. They were themselves. And what he said was every element had its own type of atom. So hydrogen atom was its own type. Helium, gold, tin, iron, oxygen, everything had its own type of atom, and that's what you can kind of see here, these different elements. And you'll notice that each element has a different circle or different sphere with different shapes or different designs in them to represent that they are different. And atoms of a single element are all identical. So if we have this atom right here, which is considered number 1, if we had 3 1 atoms, they would all look exactly the same. Basically, a circle with looks like what a colored and dot is in the middle. So these are all the same atom. They're this atom, basically, right here. Okay. The ideas that Dalton came up with is that each element had a different atom, so no 2 atoms were exactly the same of different elements, and that atoms could also combine to form what's called compounds. Now, a compound is basically when we have more than 1 atom that have joined together. So examples of compounds that we see here are nitrogen oxide, H2O or water, nitrogen dioxide, carbon dioxide. So you'll notice that we have 2 different atoms or 2 different types of things that have joined together. A little bit different than this where we have O2, H2, N2, Cl2. But you can see that these are some of his drawings that he came up with, and you'll notice that each atom is a little bit different, but they have joined together to form different types of compounds. And this is what really his big experimentation focused on. And through this, he came up with the idea that he called the law of definite proportions. Now, a proportion is basically like a division problem. But what that means is that when there was a compound, that compound was always going to contain the same elements in the same proportions. So an example of that is if we have ice, right? Ice is just water, which water, everyone knows, is H2O. So what that means is that there are 2 hydrogens and 1 oxygen. So 2 hydrogens, 1 oxygen. For just regular water or liquid, right? Again, it is still H2O. So the proportion of hydrogen to oxygen is still 2 hydrogens per 1 oxygen. As well as then, if we look at steam or a gas of water, it's still water, but it's just now in a gas form. It's still H2O, meaning 1 oxygen, 2 hydrogen. So the proportion of 2 to 1, 2 hydrogens per 1 oxygen, is that law of definite proportions. And if we were to go back to some of those compounds that we saw earlier, that's basically what he's talking about. No matter what compound it is, whether it's NO2, CO2, these proportions are always the same. Doesn't matter where I find them, it's always going to be the same. So Democritus and Dalton basically had the same idea. The atom was the smallest thing around. It was basically indivisible. It was not able to be divided into smaller things, and you could think of it as basically a solid sphere. We showed that Democritus thought different things had different shapes. Dalton thought it was always a circle, but Democritus said that there were different shapes just depending on what it was. Now, we move forward almost 100 years to J.J. Thomson. This is where things start to get interesting. Thomson actually starts to do a little bit more experimentation with what things are made of. And he was actually the first one to discover what we consider a subatomic particle. So if we have an atom right here, which was what Dalton thought, right? It was just this solid sphere filled in completely. Thomson thought that there were things called subatomic particles, and we'll do that here. So things that are smaller than an atom that are inside of it. They're smaller, they're right, below an atom in terms of size. And he did that through experimentation, obviously. And so let's take a look at what that experiment was. So what he did was he actually had this basically an electrical device where he hooked up what's called a cathode ray. And it's kind of confusing, but you can think of it as like a big TV tube. The old style, the ones that you guys maybe don't even know about, the ones that were like 2 foot in depth because they were so big. And basically what he did is he connected them to either side of an electrical device or a source of electrical current. And then what he did was he took basically magnets and a positive plate magnet, a negative plate magnet. And what he did was he exposed that cathode ray tube, and what he found is that that object actually deflected. It didn't go straight. through like it did when there was no magnet, like over here, but it actually deflected. It deflected towards the positive. So if you look at this question down here, it says, what's your guess and why? What is the charge of the particles in the beam? So this particle right here, which gets deflected, it goes towards the top here. It's basically deflected away from the negative plate and deflected towards the positive plate. So what do you think this charge of this beam must be? Well, in thinking about it, if it is attracted to the positive, we know that opposites attract. And opposites attract, then this beam right here must be negative. Oopsie. That beam must be negative. So he discovered that there must be some negative charge that's actually in things. So with his experiment, basically what Thomson found was he found that atoms had things inside them. Atoms could eject a smaller and negative particle that he called an electron. You might have heard of an electron before, and so that's really what Thomson is really credited for being the founder of. He's the founder of the electron. He found that atoms could then be divided into smaller parts, that atoms weren't the smallest things possible, but that there were actually things smaller than an atom or things that are inside of an atom, because obviously if things can shoot out, they must be held inside of it. So again, this is what you can think of as a cathode ray tube. If you look at like an old TV, again, that were really big, basically what an old TV did was it would basically shoot electrons at the screen, and that electron would be controlled by basically different magnets. So there'd be a magnet up top, magnet on bottom, and that magnet would basically change polarities at certain rates that would cause electrons to go at different locations on the screen, and that was what you would create your picture. And that's why on the old TVs it was said that you should never hold a magnet basically on the screen or wipe a magnet across the screen, because you would basically shoot all these electrons to a certain spot that would basically destroy the screen all at once. So from his experimentation and his observations, this is the inference that Thomson put together. His idea was something that they called the plum pudding model. And so what it was that he thought an atom was basically a sphere, similar to what Dalton said, but instead, the atom being a solid object, there were things that were inside that object, or inside the atom, which he called electrons. And they were basically held together by a positive charge that was all around it, because these are all negative electrons. So if they're all negative, they want to get away from each other. So there must be this positive cloud or positive charge that is surrounding them, which is holding them all together. And so for the first time, we've gone from the idea of an atom being basically a solid object or a single sphere to an idea that there are subatomic particles, or things that are smaller than atoms, which he would consider the electron. So this is a 3D model of what Thomson thought in terms of that plum pudding model.